Welcome to Spaceverse, your portal to cosmic adventures. A Nobel Laureate in physics has issued a warning regarding a discovery made by the James Webb Telescope, suggesting that it has detected something originating from outside our universe. Roger Penrose proposes that a prior universe existed before ours, and the ancient galaxies observed by Webb may be remnants of this earlier universe. Some scientists are even pushing this bold theory further, asserting that we may have already received signals from a parallel world. Penrose's conformal cyclic cosmology has generated significant attention recently. First introduced in 2015, long before the Webb telescope began operations, Penrose's work challenges conventional astronomical and cosmological understanding. Renowned for his brilliance and controversial ideas, Penrose's research blends quantum physics with consciousness and links the universe's evolution to endless cycles of creation. He argues that his theory aligns with current mathematical frameworks. According to CCC, the universe didn't originate with the Big Bang. Rather, the Big Bang marked the beginning of a new cycle in an infinite series of cosmic rebirths. Penrose suggests that our universe emerged from a precursor universe, and that we are part of an ongoing cycle of creation and destruction. Drawing parallels to Eastern philosophies of reincarnation, he posits that the universe can inherit certain qualities from its predecessor, much like the concept of karma. The recently uncovered ancient galaxies and seemingly impossible black holes might just be the cosmic equivalent of karma. They're not entirely new creations, they're the lingering effects of an older universe, echoes of a time long past. Right now, we're in a phase of universal evolution, a stage where things are unfolding in ways that challenge everything we thought we knew. For ages, scientists believed that the universe had a clear start, middle, and end. But when asked what came before or after, the conventional answer was simply nothing. However, quantum physics tells us that nothing, as we understand it, is actually impossible. So, what's the real story? According to Roger Penrose, the universe is like a living, breathing entity with a lifespan similar to that of stars and planets. Universes experience cycles, and each new cycle begins with a Big Bang. Eventually, a universe reaches its end, expanding to the point where all matter is drained and forces slow to a halt. The cosmos then collapses, hovers for a fleeting moment in perfect balance, and from that moment of stillness, it recreates itself. Just like how souls supposedly carry lessons from past lives and reincarnation, the universe retains all the information from its previous incarnation. This means that the blueprint for the next universe is always present, and because of that, matter forms far quicker in the early stages of a new universe than we once thought. The universe regenerates at a mind-blowing pace from an unseen framework, and it's even possible that massive black holes stick around during this cosmic transition. These black holes could hold vast amounts of information, acting as cosmic memory banks from which the universe pulls as it rebuilds itself. Sounds wild, right? But here's the kicker. Penrose's theories are mathematically and physically sound. And Penrose isn't just some eccentric scientist. He's considered one of the greatest astrophysicists of our time, alongside Stephen Hawking. The concept of conformal transformation, the APO phase, and infinite cycles of the universe align perfectly with Einstein's theories of relativity and other established laws of physics. Penrose offers compelling new evidence for his ideas. Back in 2015, his theories were dismissed by many, with some even suggesting that Penrose had lost his sanity when he introduced his conformal cyclic cosmology. Yet, 7 years later, his work has gained unprecedented relevance. The latest images from the James Webb Telescope revealed galaxies at the universe's edge, so ancient they shouldn't exist according to traditional theories. Other images show black holes so massive they must be billions of years old, but according to the old model, these black holes should have only formed shortly after the Big Bang. These phenomena don't fit into our previous cosmology, which proposed that the universe began from nothing 13.8 billion years ago and is a one-of-a-kind event. However, they fit perfectly into Penrose's cyclic cosmology. As early as 2015, Penrose theorized that traces of black holes from a past APO might be seen in the cosmic microwave background radiation. He suggested that certain circular heat spots could be evidence of black holes evaporating from a previous universe. Now it seems that some of these black holes may have even survived the transition from one universe to the next. Penrose has demonstrated with mathematical certainty that this is not only possible, but that it actually supports his theories. The question remains, what does the cosmic transition from one universe to another look like? Are subsequent universes merely reflections of the one before, or is there some kind of evolution at play? Penrose offers an intriguing perspective. He proposes that between apophases, changes and adjustments in physical properties and matter could occur. This means it's entirely possible that other universes were mirror images of ours, or that time flowed differently in those spaces. CCC even supports the idea of a mirror universe. Isn't this mind-blowing? Picture a universe that's a mirror image of ours, where time flows backward. According to Penrose, such a universe could have existed before ours, or even coexist with it in parallel. Scientists who back Penrose's CCC argue that we must consider the possibility of a multiverse. Quantum physics has long suggested that our universe is just one of many in a vast multiverse. Universes could exist in parallel, in sequence, or in cyclical patterns. For instance, a mirror universe might run alongside ours, with properties that are the opposite of ours in both time and physics. In that universe, time would run backward, as opposed to our forward-flowing time. This concept, called anti-time, is entirely consistent with quantum physics, and even Einstein's equations of relativity don't rule out the existence of a multiverse. Some researchers even propose that the mysterious dark matter could actually be particles from a mirror universe. These particles might travel through a threshold region, an area we can't measure, into our universe, where they contribute to gravitational effects. This suggests that there may not be a rigid boundary between universes, but rather transitions or thresholds that we currently can't detect. However, these transitions might be present all around us, and we may have simply misunderstood them until now. Recent calculations show that an untied universe might even help explain the rapid expansion that occurred just after the Big Bang. This theory is supported by the CPT symmetry, which posits that the universe must remain symmetrical when combining charge exchange or the C, space reflection or the P, and time reversal or the T. In this framework, an untied universe flowing backward in time would perfectly complement our own universe. This symmetry would not only account for cosmic inflation, but also help explain phenomena like dark matter and hyperbolic space. What exactly is hyperbolic space? It's a type of space-time geometry that naturally emerges from these ideas. Hyperbolic space expands infinitely and has a negative curvature, resembling an enormous saddle. In the concept of an untied universe, hyperbolic space serves as the framework where our universe and the untied universe coexist and symmetrically complement one another. Unlike regular Euclidean geometry, where lines stay the same distance apart and never meet, hyperbolic space behaves differently. In this type of space, parallel lines move farther apart as they extend, instead of remaining parallel. The negative curvature of space-time in hyperbolic space would make it logical for the universe's boundaries to be open, allowing space and time to extend beyond what we can observe. You can think of the transitions between universes as neighboring pools of water. Due to the negative curvature, water and possibly matter sloshes between these pools. When the water flows into another pool, it mixes with the conditions of that pool. Hyperbolic space supports the idea of an ever-expanding universe, where the geometry of space-time not only shapes the universe, but also acts as the driving force behind its expansion and evolution. When paired with inflation theory, hyperbolic space leads to the creation of pocket universes. In this model, hyperbolic space forms a unified whole, and individual universes emerge in distinct pockets within this space. A hyperbolic universe might even explain how a universe can continually recreate itself through curvature, further supporting Roger Penrose's theory of cyclic cosmology. The steady-state universe. When exploring new concepts about the cosmos, the steady-state theory is an essential idea in this cosmology. In this model, our universe exists in infinite time and appears the same at every moment. There is no clear beginning or end. The universe expands through a continuous flow of matter, which could theoretically come from parallel worlds. To visualize this, imagine water being transferred from one basin to another through nozzles, creating a flow that gives the illusion of expansion. However, space itself remains infinite in both time and space. The currents and vortices within the basin eventually dissipate, and our universe also has exchanges with other universes. This idea was first proposed in the 1940s by American physicists Fred Hoyle, Hermann Bondi, and Thomas Gold. Initially, the theory was dismissed because it was thought to conflict with the cosmic microwave background radiation, believed to be a remnant of the Big Bang. However, recent observations suggest that the background radiation may have been misunderstood in the past. Researchers have even found evidence of possible collisions with other universes within the radiation. This cosmic scar tissue could lend support to the multiverse theory and suggest that the background radiation may not originate from the Big Bang after all. And that's it. Thanks for tuning in to Spaceverse. From the mysteries of the multiverse to the wonders of cyclic cosmology, we're exploring the infinite possibilities that could shape our universe. Don't forget to subscribe and stay connected for more cosmic insights and discoveries. Until next time, keep looking up.